Hi there, and welcome to the Future Makers podcast by MAND. This is where we talk to people from scientific and high-tech organizations with a purpose. I'm Angina Herman, and Aveli Idavain is hiding under the hood to make sure everything runs. Say hi to everyone, Ave.
Hello.
Today we get to speak with Yulia Sandamirskaya. Yulia is the head of a cognitive computing research center at the Zurich University of Applied Sciences School of Engineering. That's a long one. It's ZHAW for short. She is also personally dedicated to creating better robots. Welcome, Yulia.
Hi everyone. Hi Angina. Thanks a lot for having me here today.
The pleasure is all ours. So, tell us, Yulia, why do you study and develop robots?
Well, I think there are two sets of reasons. One is I think that the robots are needed around us. I myself feel that I could need a robot in my, daily life. I'm not a big fan of routine job, especially tedious jobs that makes me, physically uncomfortable or tiring. And there are many jobs like that, out there to keep our society going. So I think robots are kind of the next big thing that could make lives of many people better. So this is one set of motivations. I think they're needed. The other set of motivation is maybe more personal curiosity. I find it exciting and interesting to work on robots. I see them as maybe the most complex puzzle in the world, many pieces that need to come together to enable smarter robots. And I also find it inspiring to think about building intelligent systems that can act in our real world environments, because that makes me also think about biological systems that do act very successfully in these environments, and thinking about how we solve all the cognitive tasks involved, but also how we control our movement, how we perceive the world. I think those are very challenging and inspiring questions.
So how did you end up doing what it is that you're doing? Did you always want to build robots, or what was your path here?
Not really always, although now then, if you ask that, I remember when I was little, I was growing up in post-Soviet Union times, and we had these journals, science and technology journals, and they had like little parts for children for like making things. And I think when I was like 7 or 8, I built my first robot out of a soap box and some toothbrushes with little motors. So yeah, I think I had some interest early on. But my way to robotics went over studying physics, which I think is a good basic studies for many things.
Mm-hmm.
At that time, I was inside myself a bit more interested in biology. So I was fascinated by complexity of biological systems. So I wanted to study biophysics, but in the end ended doing optics. I did my master's in biophysics, and then somehow ended in this Institute for Neuroinformatics in Germany, in Bochum. And there it was fascinating because on the one hand side, I was in a group that was called embodied cognition. So it had something to do with human psychology, with human thinking. It also had a lot of artificial intelligence and machine learning in the early days of this field. So that was very fascinating and exciting to see this field kind of coming into being. And then it also had robotics. So in that time during my PhD, I really was touching upon these three fields: cognitive science, artificial intelligence, and robotics. And this is where I grew as an academic. And then I focused more and more on robotics, different aspects of robotics. It was cognitive robotics in the beginning. Then we started building large cognitive architectures, and they were just running too slowly on conventional computers. And then I diverged into the field of neuromorphic engineering. This is where people try to build more efficient computers for certain type of neural network-based algorithms. Then I had a little step into industry at Intel, where we focused even more on these computing chips and making computation more efficient and faster. And now coming back to academia, I'm planning to build this larger research program where we'll put many bits and pieces together, trying to enable those smarter robots.
You mentioned this word neuromorphic, I think neuromorphic computing, whatever you're specialized in. What exactly is that?
Yeah, so neuro in the neuromorphic is about biological neural systems. So in this field, people would like to understand how biological neural systems compute, how they solve computing tasks that nature poses to them, and then try to kind of extract the essence of that computation, like build models of that computation, and then build artificial, smart systems based on that understanding of biology. And this building of smart systems goes beyond just building software or algorithms, but also goes into building hardware, computing hardware, like chips, like processors that are inspired by biological neural systems. So the neuromorphic engineering and neuromorphic computing goes all the way from computing chips over algorithms, over software, and tries to do that all in biological inspired or brain inspired way.
So is that, do you believe that it's the best way to build something artificial by being inspired from biology, or why is this a thing?
It depends. I think depending on the tasks, in some tasks, the biological systems are still unprecedentedly good. So they are much better than anything technological we have built so far. One example could be insect brains. It is amazing how efficiently the insect can do computation for vision-driven navigation, for olfaction-driven navigation, or locomotion, building some representation of the environment with teeny tiny brains that consume milliwatt of power and just have maybe 100,000 to a million of neurons. So really, really small systems. So I think there is a lot where we could draw inspiration from biology. But then, of course, there are tasks where this might be not the best systems. Like if you want to sort a huge data set or search for some very precise information, then today's computers are very good at that, better than any biological system. In robotics, I think there are many tasks where we have some elegant solutions in biology, which I think could inspire these artificial systems for robotics specifically.
So what is it that you're actually doing? So, I mean, you are, on the one hand, an administrator, essentially, at the ZHAW, but now we talk about robotics. So I think you mentioned at one point in an earlier conversation that you're interested in starting a company and to develop an actual system of robots. So tell us a bit more about that. What can we expect from you in the future?
Sure. So on the one hand side, I'm building a research group at ZHAW. We call it Neuromorphic Computing Lab. And there, so we kind of focus on two sides of the problem. On the one hand side, we are driving forward the basic technology that I think will enable robots that can work next to humans. And that technology is based on vision, artificial vision, like better cameras. So today's cameras, they evolved in the first place just to make nice pictures, right, for us to look at, and then maybe nice videos. And then we have, artificial intelligence systems that can recognize objects in these videos, maybe highlight some objects for us to look at. And it's all nice and very useful. For robots, they need to react to relevant changes in the environment very, very quickly. So today's cameras are just too slow for that. So I think we need to rethink our artificial vision technology from the sensor, so from the camera itself, to algorithms, to the larger system. We need to make it all faster and more efficient. So we work with companies that develop this basic technology, new sensors, new computing chips, and we develop algorithms for these new sensors and computers to make computer vision faster and more efficient, so that the robots are better aware of what's happening around them, and by that can be safer when they work next to humans. And potentially one day maybe even can collaborate with humans. We are a bit far from that at the moment, but the field is moving in this direction. And from the other side, from more kind of use case side, we are kind of trying to create the use case and the business case and the market for this service or assistive robots in healthcare and elderly care. So today, if you go into elderly care home or hospital, you'll hardly see any robots, driving on the corridor, either cleaning or maybe transporting things. There are some pilot projects here and there, but there are many components that need to come into place to enable this use case. Maybe the infrastructure of the corridors needs to be changed. The robots need to be built in such a way that they are accepted by people around them, that they're safe for these people, predictable. that they communicate with people, that they can be programmed easily by people who are not programmers and maybe not interested in technology that much. So they need some very easy and intuitive way to tell the robot what's the task for today. So there, I think, very interdisciplinary effort needs to take place. And we need to create a community of people who are interested in this task with different stakeholders, with the doctors and care personnel and also facility management personnel and then decision makers in hospitals and patients and their families and technologists from different levels. So we are trying to create this ecosystem that would enable these service robots in human-centered environments.
So who's we when you say that? Your research group at ZHAW, or who are you working with?
So for the first part, for the building the core technology, that's my research group with our collaborators. And we have collaborators both in Switzerland, for instance, the company that builds neuromorphic chips and the cameras, SynSense. There's a robotic company with whom we work closely, Neuro Robotics. They have a similar vision of service robots going into human-centered spaces. So that's the kind of technology team. On the other side, on this ecosystem creation team, there's a colleague of mine at facility management department, Nicole Gerber, who also has this passion of bringing technology and robotic technology into elderly care facilities in particular. And we kind of teamed up with her on several project proposals and are trying to push forward this theme.
So is this hospital as a use case one of her passions, or why is this the first place where you decided to start with your development?
So it happened to be a shared passion of ours. For me, there are a couple personal stories when I ended up being in a hospital and spending a lot of time on the corridor there and being a bit lost and not knowing what's happening and just feeling that there is a bit, maybe lack of personnel in some cases in a hospital. And I think it's also technologically maybe an environment with a nice trade-off of being a structured environment where people are used to follow, certain rules and follow certain routines, where environment is kind of predictable and structured versus, our homes, which are very, very diverse and very difficult to control what can happen in a home. But it's going away from very 100% structured environments like an industrial production floor where robots are deployed today. And the only kind of drawback of this environment is that there are no robots there today. This market basically doesn't exist. If we build the core technology for robots and then I'll go to some existing companies that sell service robots to hospitals, I will not find too many, if any at all. For instance, that's why when I pitched this idea at Intel, where I've already pitched this idea as a little startup, there Intel says, the market is too small. It's maybe too far off for us to really enter this market in a year or two. Let's better go for manufacturing. Because they still need to have more flexible, more adaptable robots in manufacturing as well. Because today automation there is mainly in large-scale manufacturing, like in car factories, but not in all this small-scale production, which is vast and vastly not automated. Nicole had this passion as well. So she comes from digitalization and bringing new technologies into facility management. And she was working with elderly houses on, the aspect how to make processes in elderly house facility management more efficient, how to bring new technologies. So there was just an overlap in our passions and vision.
Since you don't really have any examples, like you mentioned, there aren't that many robots roaming the hospital floors, then that feels like quite a big obstacle for you to be the first one. So what have you already, how has this idea been received? Have hospital administrators been excited about it, or have you even gotten that far yet in pitching the idea?
So there are some examples of kind of first movers who bring some pilot, projects or robots into hospital. So we are in a discussion with the Swiss company F&P. They have a robot, that has been introduced into hospitals and can do some transport and simple manipulation tasks there. There are a couple more examples. There were a number of European projects where people were developing, basic technologies, collaborating with startups, with small companies that bring robots into a hospital. Very often, these robots don't do any manipulation task that's complicated, but they serve as guides, for instance. So they can have a little conversation. You can ask them, how to go to room this or that, and they can guide you there. Otherwise, how people react to the idea to bring robots, it depends. So some hospital administration gets excited, they believe in new technologies. Personally, some of them are just excited about the idea of the robots, and they can facilitate, these pilot studies. How it will be when it comes to real business, and we figure out, what business model would work both for hospitals and for potential company. To survive, not obligatory to become rich, because I think it's a difficult business to bring robots into these domains with not endless budgets. We will see. We will see. I think that really needs to be worked out, whether these robots are bought or maybe only landed, how support will be organized. But we will manage to make it economically feasible.
And you see the robots as like an extra helping hand, or taking over menial tasks, or doing the things that should be very systematic and precise?
Exactly. So this is the main question. So the first thing that we would like to do is understand the processes involved in all the services, for instance, in the hospital, cleaning, transportation, and find the bottlenecks there, which, yes, either need repetition and humans, get tired and make a lot of mistakes there, or we know it's a physically strenuous task, not optimal for humans, or some tasks that could be done at night, right, or 24/7. Where automation makes sense. And in this way, find kind of the places where automation makes sense, will bring most value, will close some gaps in the processes which are today not closed because of the labor shortage, for instance. And also the tasks that are feasible to automate, maybe with the same machine, so which are simple enough. Yeah, so building a universal machine that will be able to do many very different tasks is difficult. Yeah. It's difficult. So you really need to start with very simple tasks. And then maybe this simple task can also solve be kind of applied in some other context.
Yeah, that was my other question, because your topic is completely new to me, and I just tried to Google a little bit and understand what's going on. It seems very futuristic when you explain it, because I bet in your mind you are already like 15 years in the future, knowing how it would work and how it would help and everything, and I'm just trying to be like, do I have any references from the literature or somewhere where I can think about things? And I just thought about starting from Frankenstein, coming to sci-fi like 3CPO and R2D2, and then I thought about when you mentioned the tasks. Estonia has these package courier robots that just roll around in the city. And there was a lot of pushback in the beginning for these as well, because everyone was like, oh, they're going to be in the way, and why can't humans do it, and etc., etc. But now, since we tend to anthropomorphize a lot of the machines that we create that kind of look like us or do things that we do, people help them when they get stuck in the snow, etc. And I mean, they do their job very well. So that's what I was also wondering, if the robot is something that, let's say it needs to deliver blood or something in the hospital between the floors and just moves around and does that, or is it something that a human has to stand next to and help operate and push buttons, or how would this look like?
It depends. I think it depends on, this first task of us, which task we will find need automation. And it's, of course, easier to automate the things where human doesn't need to interfere. So we can, make sure the environment is such that the robot can go from A to B, find the thing that it needs to, let's say, grab in one position and bring to the other, that it doesn't need help. There could be some other cases where the interaction is needed, where, for instance, the robot cannot grasp all the objects that it needs to transport. So the human will need to put them somewhere, put it in a place where the robot can pick them up. And then this interaction can make things challenging, because humans are difficult to model, difficult to predict how exactly they will behave. You need to communicate with them. They're just even difficult to, detect where their body parts are and how they are moving. But that's, I think, an important problem that needs to be solved. And it will be solved eventually. Yeah, so it's a trade-off. Of course, automation is easier if humans are not in the way, but the goal is exactly to bring robots in the places where humans might be in the way and be able to deal with that without compromising efficiency on the task. And that's the challenge. And acceptance of robots is a big topic too. So I think they need to be built with safety kind of first, no of humans. And then kind of error detection and mitigation, because errors and problems will happen. So the robot
Yeah.
must need to call for help or somehow find a solution. It's a bit more challenging with a robot than just with a piece of software, where someone can log in remotely and fix the problem. Here, someone might need to come over physically to fix the problem, and it's more expensive. So we need some mitigation solutions that would work on site. Yeah, this is one of the many pieces of the puzzle that need to all come together to enable these use cases.
Yeah.
Yeah, I wonder about the acceptance in particular, because think about one of the scarier moments in my childhood watching movies was definitely RoboCop, and the moment where that big scary robot walks into the boardroom and executes everybody there, which it was, of course, it was built, it was big, it was meant to look all scary and so on. But then at the same time, so many of us have these robot vacuum cleaners at home and they're cute. So it seems that we are perfectly capable of being really afraid of Terminators and robo monsters and whatnot, but then when they make it look cute and they're roaming our living rooms, then we're not afraid at all. So how big a part is psychology when you do your robot research? Do you have to put a lot of effort into that?
Yeah, absolutely. So in our projects, we involve psychologists and this user interface designers, so that they think like how the robot should look like, how it should interact with humans, so that it's comfortable for the human, understandable for the human, intuitive, easy to use. And then, of course, the appearance is very important. So all those robots that in some pilot projects are allowed to go in a hospital, they all look cute. They are all not too tall, not taller than a human, smaller than a human usually, very stable so that they don't fall over. If something goes completely wrong, it's it's a little tower that will stay. Yeah, and then if you see it, some robots that are deployed in elderly care, for instance, there's a fluffy animal robot that if you touch it, it purrs, so it reacts to you, so it has some positive effect, and it's as far from the Robocop as you can imagine it. Yeah, so I think it's an important design task. And in the end, these are tools, and of course, like any tool can potentially be used in a harmful way. I think it's important that as this field emerges, that the safety concept and kind of monitoring that it won't be misused needs to be taken very seriously. Also, safety and security, that no one can log in from the outside and make the robot do something harmful. So that all will need to be taken into account. Luckily, when the robot does something wrong, it's kind of visible. Like, if you think of some artificial intelligence agents that just work on our computer and communicate with us with the screen, a lot of things can happen in the background that we don't see. The robot is all there. So I think its mistakes will be more visible, or mistakes or misbehavior, and easy to detect. Yeah, but still, the safety first, I think, is very important here.
So what about the job aspect? You mentioned earlier that robots would be used to do menial tasks and repetitive, so essentially work that we don't want to do. But do you think that's where it's going to stay? Okay, first we give away the stuff we don't want to do, and then 50 years later, robots do all the stuff we also want to do? Or how do you see this as a threat?
Mm-hmm. So of course, like, robots are tools, and they today will be applied where they're really needed, and they're expensive tools. So they actually need to be, much more efficient, make much fewer mistakes than humans to replace a human, because it's potentially, more expensive than the human. And humans are amazing at, how they do like manual work and physical work. It's not easy to replace them. And there's a lot of work that is, for human, hard, physically strenuous, repetitive, harmful for health. And these jobs will be the first ones to automate for sure. So I think this vision that the robots will take over a large amount of job is It's so topic. It's so difficult. So our bodies are so kind of amazing. So we will have to target kind of one task at a time, starting with really urgent tasks, for which today we have lack of labor. It's hard to find people who want to do these jobs. And we don't have luxury to just, okay, let's have robot here and robot there. They're always expensive. They need energy. You need to charge them. They will break. You need to replace parts. So I think the danger that robots will replace these physical jobs, which people want to do, is much, much less than, for instance, for purely digital agents, right? That already today, might replace some job of a journalist, which is maybe actually fun for people to do. Here, I think the hurdle is much higher. So I think for a long time, if we are lucky and kind of hardworking and really this field runs successfully, we'll manage to beat robots that replace some of the hard jobs, hopefully. And that's already not easy and not obvious that we will move very fast and very far in this on this way.
One topic where this, of course, comes up, you mentioned journalists losing their jobs. So AI and large language models have, of course, been the buzzword for the past 1.5 years. How does this relate to your research in robotics? Has this hype around AI helped you with your research, or is there any connection to robotics in your kind of robotics, let's say?
Yeah. So kind of yes and no. On the one hand side, there are, of course, potentially useful tools that come out of this research. So everything like around computer vision, or the object needs to recognize objects, detect objects around it. And there today, neural network-based models or algorithms, they work very well. They have a couple challenges. So usually they work well within the realm of the data with which they were trained. So if robot happens to be in a situation where, some parameters are different than all the data sets out there, maybe it's dark, maybe it's a lot of light and a lot of contrast. Maybe there are some, shadows falling in some unusual way, then the performance of these algorithms will drop. So overall, robotics is not exactly the field where we have a problem. We have so much data. We have a lot of data, and we need some algorithm to process it, quickly, efficiently, or without a lot of manual work. Now, each robot is slightly different. There are many aspects of just mechanical model of the robot which would be good to learn, but this model is slightly different for every robot. Then the situation in which the robot is might change, like even in a hospital where things are constrained, still new objects might appear. The object might look in an unusual way, like, there can be a cup where the handle is broken and then it doesn't look like any other cup around there. So just off-the-shelf AI has developed in the field of computer vision and data processing, signal processing, text processing, seldomly can be directly applied in robotics. It can be useful, but you have to modify these models. See how we can add fast learning to those models, how we can integrate many of them, because robotics needs to solve many tasks. It's not only just recognizing objects in a picture, but it also may be localizing these objects in 3D, forming the map of the environment, planning movement, controlling movement, many tasks. And another big challenge with today's AI models is that they seldomly run in real time. So they are often not fast enough for robotic control. And we also need many of them, and then the power consumption. So what kind of computer do I need to put in this robot to support these models also becomes an issue. So if my computer now consumes almost as much power as my motors, that becomes a problem. So they are inspiring, but there's no kind of one-to-one match that I can say, like all the problems in robotics are now solved because of this tremendous success that we have in AI. And we have to think beyond today's AI in robotics to make models that are more efficient, that are faster, and that solve all many different tasks that robotics requires.
So what would you say is the biggest challenge that needs to be solved in the next few years, or in order to bring these robots to a hospital, for example?
Mm-hmm. So I think that the kind of next big challenge, inspired by success in computer vision and AI, is making vision systems that are good, reliable, accurate, precise, but also fast, real time, and power efficient, so that I can run this algorithm with onboard computing without requiring plug into the wall. So this is, I think, the next kind of proximal, to make these robots safer, make them understand the environment better. And then the next challenge after that, or maybe in parallel to that, is the embodiment, because the way how today robots are controlled, and robots come from these industrial robots that need to be very precise and very fast, but not obligatory very safe. And to be safe, they need to be softer, so that even if they bump with something, they will control the force with which this collision occurs, so that they won't hurt human, for instance. So I think the robot need to become lighter, less heavy, softer, kind of so that they are inherently safe. That even if something goes very, very wrong, they still cannot hurt a human. And that requires new ways of actuation, which is more efficient, more energy efficient, but also controlling the forces in real time. So that's, I think, the next big challenge, the actuation. And then manipulation, so be able to grasp different objects of different sizes, different shapes. Our hands are really amazing. So building better robotic hands is another big challenge. Yeah, because today for every task, I could put a different gripper, which will be optimized for all kind of tasks, but then I need to change these grippers between the tasks. So building the hand that will be as sensitive in terms of tactile feedback and as dexterous as our hands, that's a big challenge. Yeah. But then all the issues of human-robot interaction, being able to understand human, because today ChatGPT can understand text, but understanding speech, especially in noisy environments, that's still a challenge. And understanding spoken language, which is also like less kind of systematic than written language, that's another challenge. Being able to freely communicate with a human, understanding, the spoken communication, that's, I think, is another challenge.
So what do you think is the timeline here? I mean, okay, I'm asking you to predict the future, which, as we know, is very difficult, if not impossible. But how long will it take to solve these issues that you mentioned?
Yeah, we really don't know, because it could take forever, right? And in 10 years, we could be exactly where we are today, because where we are today, we have been, like on my memory, 15 years ago in a pretty similar spot. Or there could be a very fast breakthrough, right? Because we see there's some critical mass, some momentum is building up, with some visionaries pushing the vision forward, like, Elon Musk and then a couple startups here and there. Just going forward and building prototypes and bringing them, either in hospitals or in grocery stores. So I think the development could accelerate, so that maybe, in 2 years we do have more robots, and then the field starts off. So either in 2 years we have kind of maybe some inflection point where the field starts, or it could be that in 10 years we're still in the same spot.
So I'm curious, you're working in Zurich now, and is this just because Zurich happens to be a lovely city and that's where you ended up living, or is it a nice hub for robotics, or is it a good environment for your kind of research, and do you plan to continue your project in Zurich in particular?
So there are two aspects here. So first, of course, Zurich is a great hub for research and for technology development. I was attracted here because it's a big hub for neuromorphic computing. Some of the fathers of neuromorphic and mothers of neuromorphic computing, they moved here from California at some point. And there's a very strong hub, both with the Institute of Neuroinformatics at University of Zurich and ETH, also with IBM's lab. It's a strong hub in neuromorphic. In robotics, it's one of the strongest places worldwide, I would say. With a couple labs at the ETH and some spin-offs, actually a whole family of spin-offs that come from these labs. The startup and spin-off ecosystem is amazing here in Zurich and in Switzerland overall. And then, of course, the overall technology ecosystem, with the big companies having labs here, think of Google, Facebook, Microsoft, IBM, a lot of startups, smaller companies, technology, also mechatronics and the industry, like small companies that build smart devices of all kinds. Very strong field here. And then, of course, the universities, some of the strongest universities worldwide. So yes, that's a hub that attracts you. And then I enjoy being in this environment a lot, intellectually and also in terms of thinking of building my own startup, I think it's a good place to be. And then personally, of course, I find Switzerland amazing country. So it's beautiful, it's comfortable. I like the people and the mentality. I think it reminds me a little bit of mentality from my home country. And I like this respecting each other's borders and a lot of kind of respect to each other. So I have no complaints about the country. I like its multilingual nature. I like all these dialects. I find languages fascinating, and this is of course the place to be, right? With 4 main languages and who knows how many dialects. Challenging but also exciting. Yeah, so I already promised myself I'm not setting my foot outside of Switzerland anymore. That's of course again predicting the future, so who knows?
Yeah. So if you end up founding your startup, it will definitely happen in Switzerland then. Huh?
Yeah, that's the plan. And the second best place would be California, of course, which is maybe much more friendly from financing the startup and running it. But taking everything else together, yeah, I like Europe and Switzerland in particular. So I think we'll start here.
Nice.
So yeah, we've been skirting around this topic of your startup with the facility manager from ZHAW. So are you about to start it, or what's the timeline with that company? When can we start writing stories about your new startup and looking for that, seeing who's gonna invest in you guys?
So according to the current plan, so we got now some initial funding at ZHAW. There's a digital initiative Zurich founder call that I got funded. It gives a small kind of funding to try out the idea, to develop the proof of concept. So this year we focus on that. We'll try to develop a proof of concept prototype for this smart, fast camera that I envision. And if that's successful in a year, we'll go looking for possibilities for funding, how to get started as a spin-off.
Nice. Good luck.
Yeah, of ZHAW. So in 9 to 12 months.
All right.
Is the plan.
Awesome.
So one thing that amazes me when I listen to all of these different aspects is that this is a really complicated, maybe complex field with going from psychology and hardware, software, bringing everything together, biology, and you're one person who seems to be interested in all of these. How do you maintain the overview of I don't know, how does one Yulia manage to handle all these complex topics?
So it's of course not one Yulia, right? Yulia is one of the people who has passion, and I'm always looking for other people who share the same passion. And I think it can only emerge in interaction with other people, right? So I maybe trigger some conversation, and then I get something started, and then it comes back to me. And I think that's the only way how this can work with a team, with collaboration. Yeah, so putting everything together, this is something I can do, but then kind of this whole thing will be a bit vague. And then in order to crystallize itself, I need to go with someone who, a specialist and works as a main thing in a certain domain. Like for instance, we collaborate with this robotic company, Neurorobotics. They have a lot of experience in building robotic bodies that are precise and fast, but they also share the vision of going into this assistive robotics domain. So going beyond just manufacturing. So we chat with them and we inspire each other to kind of move our bit further. So I hope that interaction with me brings them confidence that we can go in this domain. And then later I hope that we can take their robot and put some of our software in it and then bring it into a hospital and then have some user study and see ask the stakeholders, the care personnel and the patients. So what do you think about robots? Behaving like this or like that, or would this action be acceptable, or how would you like to program this robot, while having it in front of them so that they now very concretely can imagine how it would look like. Now, the same with the companies that develop chips and cameras. So we develop the software, we give them feedback, we say okay, first the tools maybe need to develop further so it's easier for us to develop for your hardware. Maybe some aspects are missing, maybe we need larger chips, or maybe the power efficiency is not quite there. So we give them feedback. So that hopefully the next generation of chips will fit our goals even better, and so on. So there are constant interaction with other teams, with other groups, And this interaction first inspires me, helps me to kind of crystallize and make my understanding of different aspects crisper, and then also moves the field forward in each of the domains, in each of their like different directions, aspects, and pieces of the puzzle that needs to be moved forward. Yeah, so I'm just part of this larger system or like life puzzle that comes together, hopefully.
But you seem to be able to have this overview. So I consider myself as the kind of person who's good at top level overviews and not so much in details. But I feel like you have a broader overview still, and you still seem to go a bit deeper there. So yeah, I don't know. You need to make a robot based on your brain, I think.
Thank you.
Considering that I'm not an expert, and many of our listeners will definitely not be experts on robotics, do you have some tips for where we could go and learn more, or some interesting books or articles, or I don't know, Netflix documentaries or any kind of resources?
Yeah, so don't have very precise tips. No, there are books on robotics, but they are usually so either really fun reading and it's science fiction, or they are scientific and very math heavy, maybe not so much fun to read. Like going to fairs and exhibitions might be exciting. Like for instance, in Munich, there's this Automatica fair in summer usually, and there you can see different robots. It's mostly focuses on industrial robots today, but it's kind of sprinkles out a little bit in other domains as well. So I think going to these fairs is maybe best, because the robots, if you read about them, it's complicated math, not so fun to read. You have to see them and see them in action.
Yeah.
There are conferences, IROS and ICRA, International Robotic Conferences, which are also fun to see. They have this exhibition part, which is, at least in one of the days, is usually open to public. And there you can also see a little bit more looking forward. So the robots that are today in the research labs. And it might also be fun. So people prepare these demos and they are visionary. There's Swiss Robotics Day that happens every year, which is also because Swiss robotics is very strong. It really reflects the world, international top level. Now with the Boston Dynamics AI Institute also coming to Switzerland, I think it might become even more exciting. Yeah, so there one can also see where robotics is and talk to researchers. And otherwise follow all those visionaries, like, Elon Musk's Optimus robot, so where that's going. And there are some startups. If you subscribe to some channels on either LinkedIn or Twitter, then you'll get the latest news, what's happening in the field. Yeah.
All right. Thanks a lot. Before I move into my very last question, anything from Ave? Anything you still want to clarify or ask?
I have a silly question before the last question. If you, Yulia, could have a robot who could do anything but could still only do one thing, what would your robot do?
Me personally, it would take care of the laundry from beginning to the end. Folding, ironing if needed, putting in the machine, out of the machine, and another machine, and out, and folding, and yeah, everything is picobello. Maybe that. There's this theory we need more, like if more women would have been in robotics for longer, we would have those robots much sooner, because you really have all these chores, which are really annoying. Or a cooking robot that could cook a very nice, haute couture meal, including maybe ordering everything that's needed, it's getting delivered, and then everything cutting, slicing, cooking, arranging, full meal machine.
Yeah, the cooking one is a good one. Yeah, because the laundry I don't mind.
Yeah, I'm thinking the same as well.
And then cleaning the dishes and putting them in the dishwasher.
Yeah, the thing, I actually love cooking, but I don't love cooking every day after work. I mean, I love cooking on Saturdays and Sundays where I can, do extravagant, lavish meal planning and so on.
It's nice to have this thing still as a hobby, right? So then when you could do it when you want to. But if you have to do it every day, maybe 2 or 3 times a day. And then 3 different meals for different family members.
Yep.
Oh boy. So yeah, after you've done the hospital thing, then I'll buy your cooking robot once you build it.
Exactly.
All right, great. So, since this is a podcast about making the future and people who are the future makers, then let's try again to predict the future, even though we know that's not actually something we can do. So, Yulia, 10 years from now, what will the world look like?
Okay, I can maybe share what I hope the world would look like. So I think it would be good if there would be more technology kind of running the basic economy of the world, but we wouldn't even notice. So it will be running in the background. Now, without influencing how our planet looks like, it's still green. It's maybe even greener. More nature out there. The climate is not getting like obscene, but a lot of the kind of tasks that are required for the society to run, like I don't know, mining, building, repairing, fixing, maintaining kind of infrastructure, recycling things, that it's all automated seamlessly. That we people don't have to bother about that. Yeah, and just make sure that the system is running and do all the creative stuff and think how to go to other planets. And then on other planets, there also, of course, we would need much more robots to maybe, explore other planets, maybe also use them to get kind of more energy and so that we don't deploy our planet's resources. I wouldn't estimate this vision as very probable in the next 10 years, maybe more like 50 plus. But one can hope, right? One can put it on the wish list for the Christmas or something. Yeah. But the progress in these hardware things is kind of slower than we wish. The progress in digital technology, in computing technologies was tremendous, right? So we kind of found how to accelerate things there in the digital world, which is great, right? It also made our life somewhat more efficient, maybe more comfortable as well. But all this physical technology, when things need to move, it generates friction and things break, and you have physical materials that need to be put in place. Their progress tends to not be as fast, and probably won't be as fast as in digital technologies. Yeah.
Why is that?
Just moving matter around is more expensive than moving bits around, than moving information around.
Yeah.
It's just energetically more expensive, I think. Yeah, that's probably physics principles. But I think it's needed, and we need to think of the ways how to do it more efficiently, and also how to, find recycle energy to do that in a sustainable way. And we have a lot of human resources, smart minds, a lot of money like being spent on intelligent systems. I think we could move in these domain if we would maybe focus on it. Yeah. Yeah. Don't do wars and some stupid things, but do the smart things.
Yes, that sounds good. All right. Thank you so much, Yulia. It was a pleasure having you here as our guest.
Thank you so much. It was a very nice conversation. I enjoyed it.
And also, thank you to our listeners. And if you like hearing stories from people who make the world a better place through science and technology, you're in luck because there's more. So make sure to subscribe to the Future Makers podcast, for example, on Spotify. Until next time.